So learning target 5.3 really is just taking the equation and the graph that you just had and saying what those numbers, what that 3/7 and that 50 that we found in the previous problem mean. Because when I wrote my equation from 5.2, and I'm going to go back to that briefly, if I can get there, I did all my calculations and I found the equation of my line of fit that I had drawn through this data was y equals 3/7 x plus 50. And I actually calculated all of that to get there. If you need to see that work, please watch the 5.2 video. So the 3/7, and 3/7 if I change it to a decimal is about 0.43. It's the rise over run of the data of the line on the graph. So my line on the graph, it was roughly, and I'm not saying it was exactly this, but it was pretty close to this, let's say. It's a positive slope, and if I think of rise over run, it means a rise in temperature every time I increase the number of people. So really what that 3/7, or again as a decimal of about 0.43 means is when more people enter the room, the more people that are in the room, the warmer it's going to be. So the slope of my line is 3/7. What does this mean in the context of the actual problem? So the slope of the line is 3/7. This means that the temperature of the room increases by roughly 0.43 degrees Fahrenheit, or 3/7 of a degree Fahrenheit, for each person, each additional person in the room. Now the 50 is the y-intercept, so let's go back and look at that graph. The y-intercept is here, again at 50. Well, that's the point 0, 50. The 0 standing for the number of people in the room, and the 50 standing for the temperature. So what this really means is that if there's no one in the room, the temperature of the room originally was 50 degrees. So that's my interpretation. The y-intercept is 50, because it asks me what is the y-intercept and then what does it mean. This is the temperature of the room when no one is in the room.